Hey, this is Horner, and this is the simple harmonic motion free response question number 2. So you have a aluminum ruler and some other lab equipment, and you have fixed this to one end with a clamp or something like that, and then this is kind of hanging off. So you put a block on it, and the students ask the question, is the periodic, so it oscillates up and down. So the student wants to know if is the periodic motion of the mass also simple harmonic motion. So the student determines to perform an experiment to answer the question, and the first thing they want to know is what kind of additional equipment would the student need in order to do it. Well, it depends on how you're doing it. If you're doing force versus displacement, or position versus time, or period versus amplitude, you'd have 3 different types of things that you would need. So for the first one, with force versus displacement, you get 1 point for saying a force sensor or masses, and a 2nd point for the meter stick. For position versus time, a meter stick or motion sensor to measure displacement, and then or a position, and then video analysis or a motion sensor in order to get your time. And then finally, period versus amplitude, a stopwatch for the period, and then your amplitude, you would use a meter stick. So how would you do these? A force sensor would measure the force on the block or masses, and then the meter stick would measure that displacement. Meter stick would measure the displacement, or a motion sensor would, and then your video analysis would have time on the bottom. And then remember, motion sensors also can measure time, which is not something people think about. And then finally, period versus amplitude. Period stopwatch in order to measure how far down and come back up, and then meter stick for that amplitude. So I think I just basically went through what you would need to do with each of one of those. So I'll let you kind of read those and think about what we just said. And then for part 3 here, it says, oops, made a boo-boo there. Part 3, explain how the student can analyze the data. So here you could plot a graph of force versus displacement, and you would check and see if it's a straight line or a curve. So you would want a straight line here. For position versus time, you'd plot a graph of position versus time, and it should be sinusoidal. So it should kind of go up and down like this. That's really not truly sinusoidal. Let's change that. Sinusoidal would be more starting in the middle and then kind of going up and down. That would be sinusoidal. And then finally, period versus amplitude, see if it's a horizontal line. So this would be period t versus amplitude. This would be position x versus time. And then this one would be force versus displacement. Or delta x, and you would have that guy. So that's where your 6 points would come from for that first part. And then if you move down a little bit, you'll see it says create an example graph of each one. And so I did go through and do the example graph. So here's that force versus displacement. Here's that position versus time again. And then there's that period versus amplitude. So those are examples. In this part you describe, you don't need to draw, and in this part you would actually draw what's going on. For part B, it says the student then asks this question, does the length affect the period just as it does for a pendulum, or does the mass affect the period as it does for the pendulum? So to find out what's happening there, you'd have to vary the mass on the end and measure different periods, or you could for the other part, you could vary the length of the metal and measure the different periods. So you could do both. If the student looks at that, and if they want to see if it's simple harmonic motion, if they do period versus the mass, you should get this groot, and then that would show how it varies, period versus length, and it should vary this way too. They should both show a square root relationship, and really here you'll see t is equal to 2 pi square root of m over k. That's why your t and your m should have the square root relationship, because t is proportional to the square root of m. And then in a pendulum, t is proportional to the square root of the length. And that is where your other points would come from. And that is question number 2.